of Material Science. This slide introduces Chapter 1 of Material Science. Material Science focuses on understanding the relationship between the structure of material, its properties, and how processing affects performance. Materials shape human history from stone, bronze, and iron ages to today's silicon and polymer age. This chapter explains what material science is and why it's important in a modern society. HIP implement. This slide shows an example of HIP implement. As people get older or if they have certain diseases, their joints, especially the hip joint, begins to deteriorate. A hip implement replaces the damaged joint and restores normal movement. This example shows how material science directly impacts medicine and improves people's quality of life. HIP implement requirements. To design successful HIP implement, we must choose materials that meet key requirements. First, this material must have high mechanical strength because the hip experiences millions of movement cycles. Second, it must have a good lubricity so the surfaces move smoothly. Third, it must be biocompatible so it doesn't cause harmful reaction inside the human body. HIP implement diagram. This slide shows a detailed diagram of HIP implement components. The femoral stem, the ball, the acetabular cup, and the linear. Each part requires materials with specific properties. For example, the femoral stem needs high strength, while the linear must reduce friction. Engineers must solve problems like fixation, wear, and long-term reliability. Developing new polymers. This slide explains two categories of polymers. Commodity plastics are cheap and widely used, such as polyethylene and polypropylene. Engineering resins are more expensive but have better properties, such as polycarbonate and nylon. A key question in material science is whether cheaper plastics can be improved to match the performance of engineering plastics. Hardness, structure, and cooling rate of steel. This slide shows that steel properties depends on its structure. Different microstructure of steel lead to different hardness levels. Processing methods such as cooling rate change the structure, which changes the hardness. This shows the fundamental relationship between structure, processing, and material properties. Material selection process. This slide outlines the material selection process. First, identify the application and required properties. Second, choose materials that meet those properties. Third, select processing method such as casting, forming, annealing, or sintering. This process highlights how structure